Hello there everyone. Today we're going to talk about derivatives. Well, derivatives mainly are regular derivative. You would have to, let's say you have x to the fifth. Let's just make it f of x equals x to the fifth. To find the derivative of x to the fifth, you'll need to find that you would bring the 5 down, so it'd be 5f prime of x equals 5x to the fourth. So the regular derivatives states that to find the f of x equals x to the nth power. To find the derivative of it, you'll need to bring the n down in front of the x, so it'll be n times x to the n minus 1, as I showed you up here, this next one, and that first one right there. So let's show another one. So we'll do a little bit harder one. Let's say g of x is, let's say, 5x to the third. Now what you want to do is g prime of x, as you can see up here, we need to bring that n to the front of x, so we do bring that to the front. 5 times 3 is 15, so it's going to be 15x. We look back up here, we need to subtract the power by 1, so it's going to be 3 minus 1, it'll be 15x squared. Alright, let's now go on to a little bit harder problem, where it's an actual equation. Let's do, and also, you need to write this when you're finding the derivative, which is like a mark there. Forgot what it's called. So let's just do a simple y equals 10x to the fifth plus 2x to the fourth. To find the derivative of this equation, we will need to do y prime, that's what this is called here, equals, bring that down here, 10 times 5 is 50, x, 5 minus 1 is 50x to the fourth, plus, bring this down, which is 8x, subtract that by 1, and that'll be 8x to the third. Alright, now we are going to do an equation like we just did, except we're going to have a constant in our equation. So derivatives state that any equation focus here for a second. An equation with a constant is 0. And I'll show you this with this equation right here. So we're going to do h of x equals let's say 3x cubed plus, let's say 15. So to find the derivative of this equation, we will write h prime, never forget this, of x equals, we bring that down, multiply this 3 here by this, which will become 9x, subtract 1, 9x squared, plus the derivative of any constant, as I stated up here, is 0. If it has no constant, as in x, if there's no x's, it will automatically become 0. So the final answer here is h prime of x equals 9x squared. Now let's talk about e to the x. So, actually that was just the regular power rule. We're going to go into the product rule now. Product rule is, so f prime of x equals first time, so let's see. So it's going to be so let's say h of x equals f g prime plus g f prime. So that states the first times the derivative of the second plus the second times the derivative of the first. We're going to do a few problems with that. So we're going to do v of x equals, let's do x squared y squared. To do that, we'll do v prime of x equals x squared, because going up here first, which will be the x squared here, x squared times the derivative of the second, which is this. We will bring that 2 down here, 2y, 2 minus 1 is 1. You can just leave it as that because any variable that doesn't have an exponent is automatically to the first power, plus the second here, which is y squared times the derivative of the first, as seen in this equation up here, 2x. So some teachers may want you to write it in this form here. V prime of x equals 2x squared y plus 2xy squared. Alright, that seems pretty easy right there. We're going to go on to another equation with it. Again, this is going to be the product rule. So let's do f of x equals, let's do a longer problem with the power rule. Let's do 3x to the 5th plus xy plus 3. So the first thing we would do is write f prime of x equals, bring that down, which would be 15x, subtract 1 from there, which would be 15x to the 4th, plus first, which would be x times the derivative of the second, For this, we would just put 1. In a later problem, we're going to be using, in a later time, we're going to be using what's called implicit differentiation, which is a totally different thing. But for right now, we're going to have this as acting as an x plus the second times the derivative of the first plus, what's 3? You guessed it, it's 0. So the final answer here will be f prime of x equals 15 x to the fourth plus x plus y. Alright, so the next type of differentiation is the quotient rule. So it's gonna be g of x, or anything like y or f of x or anything. I'm just gonna use g of x. So if you have n over d, n being the numerator, d being the denominator, g prime of x would be, with the quotient rule, the denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. So let's do this problem, which would be y equals x plus 1, x minus 1. You might see this in a calculus textbook. So let's put this in view. So we're going to do y prime equals, let's look up here, denominator, the denominator times the derivative of the numerator. So we're going to do x minus 1 times the derivative of the numerator. That would go to 0, so it's just going to be 1, because if you take the derivative of x, it'd be, bring down the 1 down, x to 0 will always be 1. And then we go here, the numerator minus the numerator, which is x plus 1 times x minus 1, the derivative of the denominator will be 1 as well, as I explained for the numerator, all over x minus 1 squared. Now, some of you may think, oh, we can just cancel this out with a squared here. You can't do that, because you have a minus sign here. It's the same thing as saying 5 minus 1 over 2. 5 minus 2 over 2. You can't cancel the 2's out. So we simplify it down to y prime equals x minus 1 minus x plus 1 over x minus 1 squared. And there you have it with the first problem of the quotient rule. Let's just do one more problem with the quotient rule. So let's just do b of x equals, let's say, 3x squared over 2x minus 5. So the first thing to do is write b prime of x equals the denominator which would be 2x minus 5 times the derivative of the numerator, which you would bring that down. 2 times 3 is 6. Take 1 away from the 2, so it would be 6x minus the numerator, which is 3x squared, times the derivative of the denominator, which would be 2, all over the denominator squared. So, what you can do next is write b of x equals, let's distribute this in, so it's going to be 6 times 2 is 12 x squared, because x times x is x squared, minus 6 times negative 5 is negative 30, so 12x minus 12x squared minus 30x minus 6x squared over 2x minus 5 quantity squared. To simplify that more, we can do b prime of x equals 12 minus 6 is 6x squared minus 30x all over 2x minus 5 quantity squared. So that pretty much covered the basics of the derivatives, and as that, I will leave you with these 3 equations again. To product, you'll do, to find the derivative, it will be n x to the n minus 1. Let's just write y equals x to the n. Product, y equals fg. Y prime equals f first times the derivative of the second plus the second times the derivative of the first. And the quotient, it's y equals n over d. Y prime would equal denominator times the numerator prime minus the top times the derivative of the denominator all over the denominator squared. Alright, that's it for this edition of derivatives. If you have any questions, ask in the comments below, and ta-ra.